Hello students, welcome back. So today I am going to give a lecture on load and its determination, which is a continuation of our first lecture on the unit design against static load. So what is load and its determination? Okay, all the machine members are subjected to different types of loads that may be acting because of energy, torque or power transmission. Their self-weight, frictional resistance, inertia or centrifugal forces are due to temperature gradient. Load may be classified as static or dynamic. So what is static load now? Static load is the load which does not change in magnitude or direction and gradually increases to a steady value. Example, dead weight of machine elements. Okay. Dynamic load. Dynamic load is the load which changes in magnitude or direction or both with respect to time. Example, load acting on the connecting rod of an internal combustion engine. Impact load. Load applied with certain velocity and shock load, suddenly applied load are also types of dynamic load. Okay, next, determination of appropriate loads acting on a machine member is a critical and challenging task. Okay, so the determination of load is a challenging task for all. So all the stress and deflection analysis is useless and the component cannot function satisfactorily if the operating loads are not calculated or predicted correctly. Sometimes the operating loads are easily determinable. Example, load on a shaft running at known speed and transmitting a known value of torque. But often the loads are difficult to determine. Example, the load on vehicle switches, which depends on road condition and driving practices. Okay, most of us drive our cars, vehicles. Okay, so this point may be clear to all. Loads acting on a machine member may be directly known or may have to be calculated using basic concepts of engineering mechanics, etc. Sometimes experimental methods are used to obtain a statistical definition of the load. Also, sometimes the service loads are estimated with the help of record of service failures and strength analysis. After the determination or estimation of applied load, load acting on different members of the machine are determined with the help of free body diagrams and basic equilibrium equations of forces and moments. Failure criteria. A machine element is said to have failed when it ceases to perform its intended function. It may happen if its stress or deflection crosses the acceptable limit. Excessive deformation of a particular element may lead to unwanted interference between the machine elements or jamming of the machine, and therefore deformation is considered as a failure criterion. Some way, excessive stresses may result in yielding or fracture of a machine element, making it unable to perform its desired function. When stress developed in a ductile material reaches the yield strength, it starts yielding and excessive plastic deformation occurs. Therefore, yield strength is taken as failure criteria for ductile materials. Whereas in brittle material, very small plastic deformation occurs and fracture takes place once the stress developed reaches ultimate tensile strength. Therefore, ultimate tensile strength is considered as failure criteria for brittle materials. Bearing pressure. For components rubbing against each other with appreciable relative velocity, example bearings, clutches, brakes, etc., and wear for components having sliding or rolling action motion, example gears, bearings, bushings, piston cylinders, etc., are examples of other failure criteria. So with this I would like to conclude lecture 2. So see you all students in next lecture. Thank you. Bye bye.